Question 5. So, to calculate the tension in the string, now we're better off looking at P, as we know the mass of P, we don't know the mass of Q, so we're better off focusing on P for the purpose of working out the tension. Now we have movement, so we need to use Newton seconds, so F equals ma. So our net force, now we're going upwards, P is going upwards, so the tension upwards must be exceeding the weight of the particle. So our net force is T minus the weight, so T minus 0.4 g. So that's our net force. So that's our F equals mass times acceleration, well 0.4 times 2.45. So that allows us to work out that the tension is 4.9 newtons. Now for part 2 we're going to have to calculate the momentum lost by Q when it reaches the surface. In other words, the momentum lost is the momentum that it has the split second before it hits the surface. So how do we work out momentum? Well, it's mass times velocity. So we're going to have to work out the mass and we're going to have to work out the velocity just as Q crashes into the ground. So first of all, let's start off with the mass. So let's go and use Newton's second again for Q. So again, our starting point is F equals ma. Now this is, on this occasion, on this side we're going downwards, so the weight is greater than the tension, so our net force is mg minus T. So that's our force, our left hand side, equals the mass times the acceleration being 2.45. Well, we obviously know g is 9.8. We know that we just worked out t to be 4.9. Our only unknown is m, so we can work out that m is 2/3. Now, so that's the first component of momentum. We know that the mass is 2/3. Now for the velocity. Well, the velocity we can work out using v equals u plus at. We know our initial speed is 0. We know we're accelerating at 2.45 meters. We know per second. We know we reach the surface in 0.3 seconds. So we know that u is 0, a is 2.45, t is 0.3. So using v equals u plus at, we can work out that v is 0.735. So momentum is mass times velocity, mass 2/3, velocity 0.735. So the momentum is 0.49. So the momentum lost is 0.49. Now, part 3, calculate the greatest height of P above the surface. So let's think about it. We've got the initial height, okay, which is x, let's call it x. It's then going to go that height again anyway as Q comes down to hit the ground. Q's going to come down an x, so that's going to be another x that we go up. Then our final component is then just going to be really once we're just, the momentum just carries on us going up, and so once the string is no longer taut, how far do we go? So our height above the ground for P is going to be an x, another x, and then this y component once the tautness in the string is lost, once Q's crashed into the ground. So first things first, let's work out what x is. So the way to work out x here is the distance travelled by Q on its way down. So the distance Q travels down to the ground. So using S equals equals U plus V times T over 2, we know our initial speed of Q was 0. We know our final velocity of Q was 0.735. We know the time taken was 0.3 seconds. So this allows us to work out that the distance x is 0.11025. So we need 2 lots of that. 1 lot, 2 lots. Now our third component, as I said, is once Q crashes into the ground, the tension is lost, but P will just carry on going up a bit higher, slowing down all the time as it sort of fights against gravity. So what do we know about that journey of P once Q crashes into the ground? Well, we know its final speed will be 0. That would be the maximum height just before it starts to come down again. So we know that V equals 0. Now, key point, the initial speed of P as it starts the final bit of its journey is going to equal the final speed of Q as it crashes into the ground. That we worked out earlier on to be 0.735. So that is our U. We know we are fighting against gravity, so our acceleration is minus 9.8. So our only unknown now in v squared equals u squared plus 2as is the distance, which I'm calling y. So we can work out y to be 0.0276. So that is our y component. So adding two lots of x's and a y, two lots of x's and a y, we get 0.248 meters.